Hello everyone. In this lesson, we will learn Chapter 3, Tunnel Ventilation Power. In this chapter, we will learn what the tunnel ventilation power has and what the characteristics are. Principle of tunnel ventilator. How the ventilation equipment works. How to determine the ventilation equipment. Let's learn the first section. Natural wind pressure. We must first understand the main physical parameters of air. Temperature is a physical quantity describing the cold and hot state of an object. The tunnel is one of the main parameters representing the climate conditions. The expression methods include centigrade, Fahrenheit, thermodynamics, and absolute temperature. The pressure of air is also referred to as the static pressure of air and is indicated by the symbol P. Pressure is used to be called pressure in tunnel ventilation. It is the microscopic manifestation of the collision of air molecules with the wall. Humidity refers to the amount of water vapor in the air or the degree of humidity. There are three methods to express air humidity: absolute humidity, relative humidity, and moisture content. The mass of water vapor in each cubic meter of air is called the absolute humidity of air. Its unit is the same as the density unit, and its value is equal to the density of water vapor under its partial pressure and temperature. The ratio of the amount of water vapor actually contained in the unit volume of air to the statured water vapor content at the same temperature is called the relative humidity of air. The mass of moisture vapor in the wet air containing 1 kg dry air is called the moisture content. The property of a fluid that resists shear forces. When relative motion occurs between fluid layers, viscous resistance is generated on the contact surface of two fluid layers inside the fluid to prevent relative motion. This property of the fluid is called the viscosity of the fluid. Its size depends mainly on the temperature. Energy and pressure are two important basic concepts in ventilation engineering. They are both different and related. Energy is the basis of wind flow. Energy works as pressure. Pressure can be understood as the mechanical energy of unit volume air that can work externally. The static pressure of airflow refers to the force of air molecules acting on the unit area of the wall, which is part of pressure with the same value in the airflow. Static pressure. Characteristics. 1. Both static air and flowing air have static pressure. 2. The static pressure at any point in the wind flow is of the same value and perpendicular to the action surface. 3. The static pressure of the airflow on the tunnel section is mainly related to the atmospheric pressure. The section position, mainly the height and the function of the ventilator. 2 benchmarks for pressure measurement. According to different measurement standards of pressure, the pressure can be divided into absolute static pressure and relative static pressure. 1. Absolute static pressure. The static pressure measured based on the vacuum is called absolute static pressure, expressed by P. 2. Relative pressure. The pressure measured by taking the local atmospheric pressure at the same elevation as the measurement benchmark, 0 point, is called the relative static pressure, expressed in H. The potential pressure refers to the gravitation potential energy of a unit volume of fluid in a section relative to the horizontal reference plane, expressed in Hc, unit Pa. Characteristics of potential pressure. 1. The potential pressure is the energy relative to a reference plane, which changes with the change of the selected reference plane. 2. The potential pressure is a kind of potential energy, which has no effect on the external force, that is, no pressure. 3. The potential pressure and the static pressure can be transformed into each other, and the energy conservation law is followed during the energy transformation. When air flows, the pressure presented by its kinetic energy is called dynamic pressure, which represents the kinetic energy of unit volume of air, expressed in HV, in Pa. Dynamic pressure characteristics. 1. Only the air with directional flow has dynamic pressure, so the dynamic pressure has directionality. 2. The dynamic pressure is always greater than 0. When measuring dynamic pressure, the pressure sensing hole shall be perpendicular to the moving direction. 3. On the same flow section, due to the uneven distribution of wind speed, the wind speed at each point is not equal, so the dynamic pressure value is different. Generally, the dynamic pressure of wind flow at a certain section is calculated by the average wind speed of the section. The point pressure of the airflow refers to the pressure that can be displayed or measured at the airflow measuring point. The point pressure of the airflow flowing in the tunnel and the ventilation ducts can be divided into static pressure and dynamic pressure. In ventilation, the total pressure is defined as the sum of static pressure and dynamic pressure at a certain point in the airflow. According to the two calculation standards of pressure, static pressure is divided into absolute static pressure and relative static pressure. Therefore, the total pressure can also be divided into absolute total pressure and relative total pressure. Forced ventilation. The relative total pressure at any point in the airflow is always positive. The essence of forced ventilation is to increase the energy of the airflow at the outlet of the fan, and the absolute pressure of the airflow at the outlet is greater than the pressure at the inlet of the fan. Because PTI and PI greater than POI, so HI greater than 0, HTI greater than 0, and HTI greater than HI. HTI equal HI plus HVI. Extraction ventilation. The relative total pressure at any point in the wind flow is always negative. The essence of extraction ventilation is to reduce the energy of the airflow at the inlet of the fan. That is, the absolute pressure of the airflow at the inlet is less than the pressure at the inlet of the fan. The ventilation formed by natural factors is called natural ventilation. In winter, air continuously flows in from the wellhead 1 and out from the wellhead 5. Summer, opposite. Natural wind pressure, gravity difference of air column acting on both sides of the lowest level. Influence factors of natural wind pressure. 1. The temperature difference between the two air columns in the loop is the main factor affecting the natural wind pressure. 2. The humidity and the composition of the air have a certain impact on the natural wind pressure. 3. Well depth. Hn is proportional to the height difference Z between the highest and lowest points of the main or circuit. 4. The operation of the main fan also has certain influence on the magnitude and direction of the natural wind pressure. Control and utilization of natural wind pressure. 1. The terrain and local climate characteristics shall be fully taken into account when selecting the development scheme and preparing the ventilation system for the newly designed tunnel. 2. According to the change law of natural wind pressure, the operating point of the main fan shall be adjusted in time to meet the ventilation needs of the tunnel and save electric energy. 3. During the construction period, pay attention to the use of natural wind pressure ventilation according to the local conditions and time conditions, such as natural ventilation in the topsoil construction stage, after the main and auxiliary shafts are connected with the air shaft. Sometimes, natural ventilation can also be used. Drilling can also be used to form a circuit when conditions permit.